So let us see how it is done. So we have inserted the light wave inside this optical fiber, and the light wave will fall. So this region is the core region, okay, and this part is the cladding region, this part and this part. So this is the high index core and this is the low index cladding. So what happens, this is the denser medium and this is the rarer medium, and the incident angle, this angle, must be greater than the angle of critical angle, okay. So what will happen, all the power will be reflected from this surface and will come back to the core, right? Again, it will fall on the other part of the other side of the core cladding interface, and again total internal reflection will take place. So the all the power will be reflected back. So in this way, in this zigzag fashion, all the power will reside inside the core only, and there will be absolutely no power in the cladding, obviously under ideal condition, okay. Later on we will see that some power will be leaked. That's a different issue, but theoretically, at least geometrical optics is concerned, because of this total internal reflection, all the power will be inside the core region, and this is the basic transmission principle inside the optical fiber. Let us now try to understand the acceptance angle. Consider a possible incident light B, okay. So B incident on the surface of the starting point of the fiber, that is this point. So obviously this angle is quite large. This angle is quite large, and it is such that when B is inserted, it will follow this track, right? But here, when it incident on the core cladding interface, this angle of incident is less than the critical angle, okay. So what will happen? Most of the power will be refracted to the cladding. Get it? And that power is actually going outside of the cladding. A portion of the power will go outside and some power will be returned back to the cladding, and it will continue in its journey in this way, and after after uh, several meter or something like that, eventually this particular power will be lost, okay. So this section of the power, this light B, that is incident in this way, will not be allowed by the optical fiber. That means that particular incident ray will not be carried by the optical fiber and it will be lost, right? Now consider another ray, that this ray A, which is incident with an incident angle of theta A, okay. So it is basically the conical half angle, that is we are actually observing the fiber, uh, the cross section of the fiber in a longitudinal direction, okay. So when the A light incident on the fiber with this angle of theta A, it will be inserted inside the fiber core of the fiber, okay. And now this acceptance angle is such, sorry, this theta A angle is such that this particular ray will incident on the core cladding interface at an angle slightly more than critical angle. So most of the power will be reflected back, rather all the power will be reflected back, and eventually it will go to the other side. Then again this angle will also be slightly more than critical angle, so internal reflection will take place and it will be continued. That means the fiber is actually accepting this, or rather in other words, it is started to accepting this particular ray. And if we have another ray which incident, that incident on this fiber, or inserted inside this fiber with an angle less than theta a, then obviously that particular ray will also incident on this core cladding interface with uh, incident angle of more than critical angle, and it will also be accepted by the fiber. That means it will follow this kind of zigzag path inside the core, and it will be the ray will be continued. Okay, so what we have seen, that we have an acceptance cone. Okay, acceptance cone with conical half angle of theta a, from where if we try to insert the light inside the fiber, that particular light will be carried by the core. And if the light incident on the, if we try to insert the light um, with an angle greater than this conical half angle, that particular light will uh, actually be lost by radiation, just like this one. Okay, that means there is a definite direction. Okay, there is a definite direction from which the light will be accepted by the fiber. And if it is, if we try to insert the light inside the fiber with other direction, that will not be accepted, right? And this angle is actually called the acceptance angle, right? So theta a is the maximum angle to the axis at which light may enter the fiber in order to be propagated, and is often referred to as the acceptance angle for the fiber. So this acceptance angles is very important parameter for optical fiber communication, because this angle allows us to estimate the direction of the incident light. Okay, from where we can easily insert the light inside the fiber. Okay,